first question is an absolute value. So the idea of the absolute value is to first isolate it. Okay, so I'm going to do some algebra, add 5.
Yeah.
Divide by 2. Okay, so what is the idea with absolutes? If you have the absolute value of 8, that would give you 8. Or the absolute value of -8 is also 8. So this will get split as 2 options, where I'm stating the inside of the brackets could have been 8, or the insides of the bracket could have been -8. And then finish out your algebra here. Good? So isolate it, split it. If you ever had an absolute value equal a negative number, what would we write? No solution. Okay, solving the systems of equations. You betcha I put one on there. So let's start with a label. So 1, 2, and 3. Yep. More? Is it glaring up with more?
Thank you.
Okay, did we pick one of the letters to get rid of? Which one looks the easiest? The Z. So I'm going to eliminate the Z, and I'm also going to eliminate the Z again. I'm committed to it twice. Okay, we just have to pick 2 different combos. So what are we doing for right now? 1 and 2. Okay. You will add or subtract to get rid of them. Add. And again, on the test, the most mistakes I saw were just in the adding or subtracting the integer numbers. So go slow and steady. I'm going to label this now equation number 4. It's a different equation now. Okay, we have to pick another. Do you want to do 1 and 3 or 2 and 3? 2 and 3? Okay, so 2 with 3. Okay, looking at the Z's, the question is add or subtract? Add. Okay, equation 4 and 5 will need to be put together. So what do you want to do as a matchup, the x's or the y's? The y's. I'm going to take equation 5 and I'm going to double it. Does that make sense why I'm doing that? Make sure you double everything though. The 7 gets doubled, the 1 gets doubled, and the 11 gets doubled. Okay, 2y, 2y. We're now going to subtract . Okay, so remember we kind of funneled down. Now we're ready to go back up. So we start the plug-in process. Where would be the first place to go plug in something? 4 or 5? It doesn't matter. I'm going to go to 5. So 7 times 1, plug in. Okay, plugging in, working your way back up still. So now you have to pick 1, 2, or 3. I'm going to pick equation number 1. Bless you.
Thank you.
Anybody matching my final 148?
Can you go back?
Okay, where did I get 8 from? Oh, yeah, why I did this, nope. I did this as a 7. I need to times that. 13, did you get a 3? I see what I did. You know what I did with 3 and 4? I added them.
Rookie mistake. You know what?
Rookie.
You weren't keeping within half of the test.
I know. This is what math looks like when you're sleep deprived.
Dad, you know what? I think we were just testing. We were testing us to make sure we knew what
Yes.
we were doing.
That wind kept me up all night. No sleep. This is what happens with your math. You add numbers instead of multiplying them. Okay, 1, 4, 3. Is that right? Okay. Okay. Systems of equations. So solving equations, you have a few strategies. Grade 10, you learned you could eliminate them, right? Stacking them on top. You could substitute, or you could graph something. What method would be the best fit of this question? Substitution. Y equals x squared, so I can substitute that in. Okay, I'm very impressed with your class's ability to figure out what to do next, which is
You have to move the 4x and 5 to the left.
0. 0 one side. So do you remember when I said you have to master your factoring skills? See how they come into play all the time? 5 times 1. Okay, I had people on the test stop there, which is 2 points out of 3. You have to plug that in. I want to know what y is as well because I have a y variable involved. So negative 5 comma what and 1 comma what. So what, it doesn't matter which one you pick. I'm going to go with the first one. What happens to y if I do a negative 5 squared? Positive 25. What happens to y if I do a 1 squared? 1. Okay, number 2, what strategy would you go with on this one? A substitution or elimination? Because I'm not even going to say you're going to graph that. Eliminate, and then you actually have 2 choices. You could go with the x's, x squareds, or the y squared. You pick what you want to pick. I'm going to pick Okay, do we remember that this would involve a plus minus?
Yeah.
When I go back and substitute, I can simply replace x squared with a 25, right?
Oh, yeah.
I don't have to worry about going back to think about 5 squared, da da da. I can just say, well, x squared is right here. Well, I can just maybe replace that with a 25. So, do you understand that that's producing 4 coordinate answers? There's 4 points where these intersect. This one is a circle, and this one is a hyperbola. And we get to graph that in advanced math. So the circle and the hyperbola will have 4 coordinate intersections.
Do we need to write down?
No, but I'm just making you understand. Don't forget your plus minus. That makes you not forget your plus minus.
Hey, you know what I figured out about math? Just add plus minus to everything. You can't be wrong.
No.
At least one of them has to be right.
Don't do that. Okay. Inequalities. So, step 1. Tell yourself, where does this actually equal 0 first?
You need to take out the x. Yeah.
Take out a x, so a GCF style. Trinomial.
Does it equal 0?
It equals 0 in 3 places.
Okay.
When x is 4, my equation would equal 0. As in, if you put a 4 into this, it'll come out as 0. 4 cubed, right?
You want to be greater.
When you put a 4 into that equation, it will equal 0.
You didn't have 4 yet. So
I'm going to use a number line. I'm going to place a -2, a 0, and a 4 as x values. And then I'm going to analyze what's happening to the y values.
they don't equal 0.
So specifically, at those exact points, my y's are equal to 0. And then what's going to be going on in between those points? So I'm going to test -5. I'm going to plug them into the 3 brackets. Again, if you really wanted to, you could plug it into the original and figure out your exact number. But this is faster, it should be. Each bracket would be negative, negative, negative. So 3 negatives multiply to negative. So that region of the graph is below the x-axis. I'm going to test -1. So -1 would be this bracket, negative. -1 minus 4 is negative. What is -1 plus 2? Positive. So that would be 2 negatives, making it positive. In between, I'm going to test 2. 2, positive. 2 minus 4, negative. 2 plus 2, positive. So 1 negative in there. And I'm going to test anything above 4, 10. 10, positive. 10 minus 4, positive. 10 plus 2, positive. Okay, so that was the analyzing piece. Now the question says, where was it less than 0? So negative is less than 0.
Negative infinity.
And would you include
Yeah.
or not include the numbers?
You don't.
You don't, because it's not equal to 0. So I would write, I'm running out of room here, negative infinity to -2, round bracket,
Then 0 to 4.
or 0 to 4. Yeah, if you want.
Can we read a cheat sheet?
No. If you take applied, you can. Or essentials. Okay, question B is already factored for us. So the x values are 3, 1, and -2. Okay, test. So I'm going to test some x values. So let's go with -6 maybe. Don't forget you have 4 brackets. This is where people make the mistake. There's 4 brackets to put it through. You have to count that twice. So negative, 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 and then negative. There's 4 negatives, making positive. Ooh, 0's in this zone. I'm going to test it. So pretend you don't even see the x. This is -3, -1, so negative, negative. +2, +2. So that is positive. I'm going to test 2. 2 minus 3, negative. 2 minus 1, positive, positive, positive. 1 negative. And then I plugged in a 10, and they all were positive. So now that you've analyzed it, do you know where you're going to be greater than 0 or less or equal to 0? Greater than I can be on, I can be greater than, I can be on, I can be on and greater than. So those are all that worked. Okay, so I know that this was two separate intervals, but I can actually write that as one interval because I don't have anything that I have to stop at, right? I actually include every single x in that interval. It would be separate if this was a not equal to sign, then I would have to separate it. Okay, so that's the intervals, and they're square brackets because I'm allowed to be on them because I'm allowed to be equal to 0. And the last example. Okay, number 1. Algebra. Here's what I'm going to do. I'm going to say the plus 3y stays. The plus 3y stays. And then there's a less than sign. Can you move the x and the number? So negative 2x plus 15. Did you move algebra correctly? That makes sense algebraically? And then I would have to divide by 3, divide by 3, divide by 3. Okay, so I'm going to do a plus 5 y-intercept. And I'm going to go down to right 3. What kind of line will I draw? You have your two options as a solid or a dashed. A dashed line. And then I have to pick a side. So you have these two options, and it says to be less than. The yellow one is the less than. I'm just going to give myself little arrows to say, make sure I'm on that side. Okay. Line number 2. I'm going to keep the y. So negative 2y stays. I'm going to move 3x, and I'm going to move the negative 8 over. Okay, I'm going to now have to divide by negative 2. There is a 100% chance that I put one of these on the test, on the exam.
You have to flip the sign.
You have to flip the sign. I put that on there on one of the lines. Don't forget that rule. If you divide by a negative in your math, your sign actually gets flipped around. Okay, somebody said positive, right? Positive 3 over 2 now. Because the two negatives, positive. Okay, so negative 4y intercept. Up 3, right 2. Dashed your solid. Solid. And then the greater than direction now. So the final solution region is any coordinate in this region. Okay, so these were the graphs. So this I asked you in words, but you better understand the notation. This would be if I asked you to graph the absolute value of a function, right? The absolute value bars. So what do we know about absolutes?
They can't be negative.
They can't be negative. So if it was 0 or positive, it would just stay where it is, right? And if it's negative, it would change. Okay, so I'm going to have to show you an overlap. This portion of the graph will stay there. It will not move. It will get overlapped. And then the portion that is negative will turn positive. Specifically, I'm going to take the coordinate 0, -3 and move it to 0, +3. So that's what my graph will look like. And the reciprocal as a notation would look like that, 1 over the function. So you're dividing each y value. So let's talk about some specific y values that are important. What happens if you take a y value of 0 and go 1 divided by 0? What happens? Undefined. How do you graph the number undefined? With an asymptote. So you have 2 asymptotes at x equals -4 and x equals 3. Another y value that's important when you reciprocate is the y value of 1 or -1, because what happens when you flip that number? What happens if you flip 1 as a number? What does it turn into? 1. So any y value with that would stay. So where do you see y values? There and right there. Okay, now you fill in the rest of the pattern. So looking at where my pen is, this little tiny section of the graph, do you understand this section of the graph has values, y values, that are close to 0? So now I will move my y values away from 0. And I'm going to do the same on the other side. And then I'm actually going to take a specific point here, 0, -4, and move it to -4 would move to -1/4. Because it was the lowest point, so now it should be the highest point. Does that make sense?